All right, today we're going to be looking at the linear regressions packet, and we're going to be on the first 2 pages talking about line of best fit. So a line of best fit is basically just a linear representation of the data that allows it to be most accurate with all the points given in whatever data set you're looking at. So let's look at this first example. Mr. Templeton's Future Business Leaders Club, FBLC, is helping a frozen yogurt shop located near the school and analyze how the business is affected by the weather. The owner is wondering whether there is a relationship between the temperature and the number of customers that buy yogurt during the 2 hours immediately after school. The FBLC collected this data. So right below that, they give you a table. The X column right here is talking about temperature. So this is going to be our X values, and then the number of customers is our Y values. So number 1 says to construct a scattered plot of the collected data. So basically we're going to take these points from the table and we're going to plot them on the graph. All right. So on your paper, you can see the first point is 45.97. So this is my 45 on the x-axis, and then I'm going to go up to 97, which is almost to 100. So I'm going to draw these dashes. I'm going to draw these dashes, and it's going to be right here. All right, then our next point is 25.55. So 25 is right here, and then 55 is right there. All right, our next point is 60.85. So 60 and 85. Oh, that's on 80, so go up 1. 15.37. And then the last one is 100. All right, number 2, after you plotted all the points, draw a line on the graph that best represents the data. So we want to draw a linear line that best represents this collection of data. So I'm going to take my ruler, and I want to try and do my best to hit every point or be close to every point. So I'm going to say this would be my line of best fit. Okay, and that's just an approximation. So it doesn't have to look exactly like mine, because we're going to figure out how to find the real one in just a second. All right, so use the linear model to describe the relationship between the temperature outside and the number of customers at the frozen yogurt shop. So this is question number 3. So from here, from our graph, as we can see, that as the temperature is increasing, our number of customers is increasing. So that's what I'm going to put there. All right, so that's defined as a positive relationship because the slope is positive because the graph is going up. All right, number 4 says to write the equation of your approximated line. So instead of focusing all on approximating, I want to show y'all how to do it on Desmos. So we're going to go to Desmos. All right, now that we're on Desmos, we are going to make the table that is on our paper. So if I come up to this plus sign and add a table, okay, I'm just going to type in the numbers from the table. So 45.97, 25.55, 60.85, 15.37, and 100. And if you zoom out, there's our graph. All right, so now to find our line of best fit, I'm going to come to the number 2 line, and I'm going to type this formula in. All right, so I type Y1, and then if you click the ABC button, I'm going to come down to the bottom and put that little squiggle. And then MX1 plus B. And that makes your line of best fit. All right, so if you look closely at parameters in that number 2 box, it says M equals 0.686577. So that's going to be our slope. That's our M value for our equation. And then B is 41.1577. So that's going to be our y-intercept. All right. So I'm going to go back to my notes. And for your sake, I want you to write the formula down. So I want you to make sure that you highlight the M and the B so that you know when you're doing a problem on your own that that's what you're typing into Desmos, and those are the 2 things that you're looking for. So now I'm going to write R's. So this is our line of best fit equation from this data. All right, number 5, it says based on your equation, predict the number of customers to visit your yogurt shop in the 2 hours after school given these temperatures. So I'm going to use my equation. And I'm going to put 85 in for X. Then you can plug that into your calculator, and when you do, you should get 99.52. Okay, this is what you would type into your calculator. All right, for part B, we want 115 degrees. So I take my equation, I'm going to plug 115 in for X. This will get typed into my calculator, and you should get 120.112. All right, let's look at the next page. So on the top of the next page, there is a number 6. So it wants you to go to Desmos and create the line of best fit, and we already did that, so that is why we crossed through that. All right, so the equation that your calculator uses to give you the line of best fit is called the least squares method. This method creates a line of best fit for a scattered plot that has two basic requirements. The line contains a centroid of the data, and that the centroid is a point whose x value is the mean of all x values of the points on the scattered plot, and its y value is the mean of all the y values on the scattered plot. Even though infinitely many lines can pass through the centroid, the regression line has the smallest possible vertical distances from each given point to the regression line. The sum of the squares of those differences are at a minimum with this line. Okay, that's just a bunch of vocabulary and stuff that you really don't need to know for what we're doing with this information, the project that goes along with this, but I wanted to put it in there just so that we can say that we talked about it and we referenced it. But really, Desmos is going to be doing all the work for you when it comes to finding your line of best fit. So we're going to do one more example. The table shown lists the average global temperature in 5-year spans from 1957 to 2016. All right, so number one, it wants us to find the range of the data. All right, so to find the range, you're going to take the highest temperature, okay, your highest y value, your biggest y value, I guess I should say, which if we're looking at our y values, which this is our y values right here. All right, this is going to be our largest y value. So I'm going to take that value and I'm going to subtract it from our lowest y value. So looking at your table, this is going to be your lowest y value. Then you just subtract those two together and you get 1.327 degrees Fahrenheit. All right, number two wants us to identify the independent and dependent quantities and their units. So independent is our x-axis, which is going to be our number of span in years. So that's this column. And then our dependent quantity is just the average temp of those 5 years. And that's in degrees Fahrenheit. All right, number three, we're going to use Desmos to graph the scattered plot and identify the regression equation and the line of best fit. Sketch the graph below. So first, this graph does not come labeled for you, so I want you to label this graph. All right, so go ahead and line up your graph how mine is labeled. All right, next we're going to be going over back to Desmos, and we're going to be putting these two columns into Desmos. So let's go over to Desmos. All right, so now that we have graphed our graph in Desmos, okay, it should look something like that. We're going to create our line of best fit. So that means I'm going to come to line 2 and I'm going to put our formula in. Y1 squiggle M X1 plus B. All right, and again, it gives us those parameters. So now I'm going to go back and put those on our graph on our notes. All right, and then we should have it graphed right here. So your graph should kind of look like that. That's a very rough graph, but it should look something like that. So now, based on our equation, we're going to predict the average global temperature for the years 2032 through 2036, which that's going to be span number 16. So using my equation, I'm going to plug 16 in for X. And when I do that, you should get 58.877 degrees Fahrenheit. And that completes the first set of notes for the linear regression pack.